Good morning, hello, happy Monday, everyone. Hope you had a great weekend, and I hope you have a great day today. Let's see where we're at again. Right, we are at the, I guess in entity data here. When we're doing the query for multiple things, and we have different what would it be? We have different number of elements inside, like different number of components for each entity. So the arrays or the vectors are no longer aligned, meaning that they're not the same length anymore. But we have our bitmap, which is going to help out a bit. So we have that passed in here through query. And then what we can do is we can somehow use that query to figure out what indexes to go with. So I was thinking last night, and the way I was doing this obviously is a little bit wrong, but it's not like so far off. Basically, I think the first thing that I want to do here is do a query from the bitmap first. And it's going to be the same thing we do here. We're going to hand it the name. So instead of like a query of like just getting one thing, it'll be a query of getting all the things. So we'll have names, and this will be a vec of stir, and is that all I need? Just a vec of stirs, I think. I think so, because I don't really care about types at this point in time. It's just the names. So okay, so what we're gonna do is have the same exact thing that we do elsewhere. It's gonna be a result of a vec of Boolean. Now, I don't think it's gonna be quite that simple anymore, because it's gonna be a vector of the vectors of Booleans. So it's gonna be a vec of bool. So we have a let result. Well, it's an empty vector. And we'll return the results at the end. That should make you known. Oh, it makes you need to be an okay. That should make you known. Okay, so then we want to grab this. So self entity map. Okay, so then we need to loop through. Let's actually just do this really quickly. We're gonna loop through the names and get these results. So name in names. Then from there, I want to grab this name. So if let some, this is going to be our map equals self dot entity map that get name. Okay, so if we get that, then we have our map, which is this vector of a bool, and I can push that into the results. Now, does this make sense? It's a vector of bool, so we're going to have this vector that holds vector of bools. Yeah, we own the vector, and then that. Okay, I think that works. So results dot push the map. Now, if it doesn't find it, we want to immediately return an error. Bitmap component not found, and this is going to be the name to owned. So if we reach the end of this, we should be able to return the OK, and so that gives us our query. So we're going to do this the very first thing in this function. So we're gonna say let it's gonna be the our map. I wonder if we should actually have this like passed in, so I don't have to like do this as a weird query like this. That might be better. So what if we have like the bitmap being the actual just the query itself? So which would be the it's gonna be a vec of a reference to vec of Boolean. Then, okay, so how are we gonna go about doing this? I might want to just like reset this a little bit. I actually want the thing that like has the most information that's the most useful is the bitmap itself. So I kind of want to loop through that, but also we have a problem of for each of these. So we have to loop through we have the number of components that are coming in. That's going to be like the down, and then we have vectors coming in like this. So head over to our whiteboard. Actually, it's this thing right here. So what do I need to do? We basically are going to have this as our bitmap coming in. And this vector is actually doesn't have this one, so this isn't an index. So it's like 0, 1, 2, 3, whereas this is 0, 1, 2, 3, 4. So the links are off. But this one has that all. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so we know we can start with the bitmap. If all of these are true, based upon what's queried in, if everything is true here, then the index that we're tracking, so we're starting with index 0, then we want these, so index zeros. Then we come here, index 1, that's fine, so we take these. Index 2 is fine, we take these. Index 3 is not fine, but I need to increment this one, not increment this one, increment these two. So that way, this next one, index of 4, really gives me index of 3 here and 4 for the rest of them. So I need an indexes. And you're going to have to be a vector, but inside of the vector, we're going to have the current index. I think so. And the way that we're going to have to do this is you're going to start with 0, and you're going to be of size whatever the length of this is. Either names or bitmap, it doesn't really matter. They should both be the same. So we can do names dot. So that should give us indexes to reach into. Then we're going to loop through the bitmap because that controls this. So I'm actually just going to reset you. Results, I think this is fine to keep here. But I'm gonna undo you. So for map and bit map. So I guess it's really more of a row. Or bit row. I don't know. That it seems wrong. But okay, that's gonna give me the first vector in here. And is that even correct? I don't even think this is correct. This is more like, okay, so index, for index, like bitmap index in, and I want 0 dot dot bitmap. It's like the first one. Okay, so go until like the length of here. Then I can manually check inside of the bitmap and inside of like the names and everything else using this bitmap index. So if all of the things are the same, if they're all true in the bitmap, so if bitmap of now we have like the downward slice, and then we're going across. So I want to check all of these first. So for the first one, I want to check all of you. So that's going to be the first item of the bitmap, but then I need to loop through all of these. So if bitmap of index 0, so that's where we're starting here. If all of you are true, but the problem there is I don't know what all of these are, right? Because I don't know how many we have. Like it's going to be if bitmap 0 is true and bitmap, is that right? So like 0 of the bitmap is actually all of these vectors. So I need to check 0, 0. Does that even make sense? So bitmap itself, bitmap of 0 gives me all of these, right? Is that correct? It's a vector of vectors. So bitmap of 0, I guess just gives me this first one right here. And bitmap of 1 gives me the second one down here. Because the first row is the y's, essentially. So bitmap of 0 gives me this, give me 1 gives me this, and then of that, inside of those, I want of 0. So essentially it's going to be bitmap of this bitmap index of 0, so like the first one through. So I don't want to do this as bitmap length. I probably do want to do this as the bitmap index in so the bitmap in, maybe we can call this like bitmaps. So bitmap and bitmaps. And that's going to give me like this one, and then this one, and then this one, and then this one. So if that bitmap of the index, so we also care about the index, right? So how are we going to, so as we go, we need to go down, and then we need to go across. Because this one will loop this down here, and it won't return back up and do this one again because we just went through here. So I wonder if we need like just a loop, like an infinite loop, and then we'll like break it manually. And then we can say, okay, give us like this first one, 0, 0, then 0, then 1, 0, then 2, 0, then 3, 0, and then it could be like 0, 1, 0, 1, 1, 2, 1, 3, 1. And if we do that, we want to, okay, so we have our results. I don't think this is right. I think we have to do a loop. And then we'll break it as soon as we reach the end. We know we have the bitmap index that we care about, which is the one coming down to here. And then we have the length of the ones inside. So we have the length of the bitmap index, and then we have the length of the names. I guess that's really what we care about then, right? So we want to go all the way through. I'm going to go down through the bitmaps and then keep on repeating that, but grab the keep the index of like what the current name is on. So if we do like let, well, I guess like we have these current indexes here. So that's what we're keeping up to date, is like this is 0 to like go into the names. So we'll call this like the name indexes. They're going to go into the results, and we need to check to see if we're going to keep it. So in this case, could I just loop through the names? No, I can't, because I can't loop through the names. I can't do like the number of loops for the names because I don't know if it's the right size. But I might be able to do a loop through for that index in one of the bitmaps because they're the guaranteed length. And if I only care about the index in here, we do that first thing that I was thinking about. So for like index in 0 ... bitmaps, it doesn't matter which one. We can do 0 because we don't know how many we have, but we should have a guaranteed of 1 at least. That length. Okay, so then that gives me, we have an index across this entire thing. So then for each one of those indexes, I want to loop through the current bitmap that we're in and check to see if they're all true. And we want to just loop through the bitmap with the new index. So then in here, we want to do a for, actually rename me back to bitmap. I think that makes sense in this case again. Okay, so for, this is going to be bitmap row in bitmap. Okay, so in bitmap, then I want to test this specific one here, then this specific one. So if bitmap row of position index So if that's true, then we're good to go. And if we reach the end of this interior loop and we're still true, so maybe let our flag, so like has all, let's see, has all components, like does entity have all components? We're gonna set this to be false, I think. Then if you're true, okay, so if bitmap row of index, we set you to be true. And actually, what if I do set this to be true here? And if this is a not, so if bitmap row index is not true, then I want to break out of this loop. But if that is true, what do we need to do? Before we break, we need to increment all of the name indexes except the one that we're caring about, which is this index here. So like the first one, if that's a false, we don't increment it, it stays a 0. But the other ones stay true. Oh, does this need to be a vector of vectors? I think this needs to be like a vector of vectors. It needs to essentially be a clone of the bitmap, but turned into vectors. So this is going to be so this first one is we want this to be the bitmap dot length, and this other one we want you to be a 0, and you're going to be names dot length. Then we're going through, this is this should be the names dot length to go like across. Oh wait, no, wait, never mind. I remember why I was doing that, because we don't know the names dot length is the right length. Okay, then I don't know if I need this flag even. For bitmap row in the bitmap, if the bitmap row is index is not true, that means it's false. We don't have it here. That means everything needs to be incremented except this specific one. I guess like, and then I don't add it into the result if we're not doing this. So that just does mean I do need to, I can't break, I don't think, because I need to actually finish going through these to increment these name indexes. So if you don't exist, name indexes does not get incremented. So I wonder if I need to do this like in 2 passes, and I don't want to do this like just in a single pass. So If I did it in 2 passes, it would be the flag that like we're not going forward. And then we're going to increment name indexes, except for the one that's, well, not there. So we need to check if like you all exist. And if you don't exist, we need to know which one. So how do we do that? Looking through this, we want to, so we're going through all of these, and we grab this first one. And we're gonna look to see, okay, if you're true, but I can't do anything, like this doesn't tell me any information because this is the same as this one, right? If you're true, and if you're true, and if you're true, and if you're true. So I have to loop through all of them and check to see if you're true, which means I need a flag. So let, does entity have all components? I don't know what this should be. I'll set it to be false for right now. That may need to be something else later. Then, if you're true, I want to set you to be true now. So we go through that entire vertical and we check to see, okay, is all of you true? However, if any single one of them is false, I need to break out, like this needs to be false here. No, because like if the first one is false, let's say this would be false, and then the next one might be true, and that's not going to help me there either. So like the flag, the way I have it right now is not helpful. But I don't necessarily want to break early unless I'm just doing one pass to check and another pass to then add in to update like the name indexes. If I do that, I wonder if I should break this out into different functions, and that I wonder if that would help me out here. So basically, what we're going to be doing is checking the first vertical. So for each of the components in the bitmap, that would be like all like the down, like the 4 down. For each of these, check to see if the current index is true. Check to see if they're all true. Are all, I guess, oh, you know what this is? For each entity. For each entity in the bitmap, are all of the components present, are all the components queried for present? So that would be something like, let's say we're only looking for these 2 right here. Then, are you present? Are you present? Are you present? Are you present? Yes or no? Are you present? Are you present? So for each entity, checking to see if all of those are present. If yes, we want to add the components into the results vector. And we want to update the name indexes. If no, we don't want to add the components into the results vector, but we still need to update the name indexes for present components only. And then we continue on, right? So then we go on to the next entity. Let's start that over again here. We're going to do for entity index in, and this is going to be our bitmap of 0 dot length. It doesn't really matter which one, so we'll get that one. Oh, and it's going to be, all right, so we have our entity index. So we can grab that entity out. Are all the components queried for present? Now, this thing is update the name indexes. This is going to be more interesting because I don't know if that should be broken out. Because I don't know if we can do this simply here. Like this is like add the components into the result vector. I think these are gonna have to be essentially their own little mini algorithms after the fact. We just have to check to see if yes, add the components into the results vector. So we have our entity index. Now I want to go through all of the components and check to see if they're true in the bitmap. So flag here. So let mute so all entity has all components equals, I think we can mark you as true because we can break if any of them are false. We can skip if any of them are false, really. Now, is that true necessarily? Well, regardless, we're going to be updating the name indexes. And we have the entity index for the name index here. So the entity index is across. And then the down is going to be our components index. Or like the query index. So all of the, okay, so I'm getting hung up on the, like, do I need this flag or not? I don't actually know. It's like I might be able to do this without the flag here. If so, I guess what I need to do is I need to check them all, and then, but I can update the names. I can update the name indexes as I go along. It's almost like I can do that here. Update the name indexes. So for each entity in the bitmap, and then we would have to have for each component in the entity, update the name index. And then we're going to come back down to here. Oh, that was not fun. Okay, so take the name index. But then after this, so we go through the component. So we have to check to see if are all components queried for present. That's essentially here. If yes, add the components in there. The only way, okay, so then for each component in entity, so that's going to be right here in another for loop. So for component index in, and this is going to be the bitmap dot length. So now I'm going down through the bitmap. And so then this could actually just be for component bitmap in bitmap. Then I could check the components of the entity index, and if you're, if you're false, if you're true, that's depending upon what you have in them. So we're going to update the name index first. So we have that now with the components bitmap. We need to enumerate this. So we have the components bitmap index, and then the components bitmap itself. If this is true, we're going to increment this name index. So if the components bitmap of entity index, if you're true, then I want to say name indexes, and so we have to first go through the components bitmap index, and then we have to go through the no, is that true? I don't know if I need an index vector of vectors, right? Because it's the current. We're looking at the current one, aren't we? And do we even need the name indexes the way we're doing this? Probably. Yeah, we do. Okay, so this is the current yeah, name indexes. And you can just be 0, but the bitmap dot zero dot length. No, bitmap dot length. It's just zeros down, but then that's going to increase. So then name indexes of you. You do exist, so you're going to plus equals to 1. Okay. So as we like track these, then this is great and all that we're like be able to you know, like know what the current index is, but it's only like part of the battle because my lovely pseudocode is not happy here. So basically we're doing for each entity in the bitmap, and then for each component in the entity is here. We're updating the name index. Just happening right here. Are all of the components queried for present? We can use a flag for this because we have to go through all of these. So that means we're gonna have to flag here. So let's is adding component. You're gonna be true if the component's bitmap. So if you're false and you don't have this, then is adding component becomes false. And at the end, if this is false, because we're only ever going to set it false, we're never going to set it true also. So if it's still true at the end of this, then we found them all. Now this is only for the vertical. This is only for the entity because this is going to go reset back to true for each of these down. So then we come to the end of this for loop. Are all the components queried for present? If yes. Okay, so this is now if is adding component. If this is true, add the components into the results vector. So then we want to, we have our current name indexes. We can loop through those and then add the, I guess query the names in, right? So I haven't even queried for the components yet, which we should probably do. We have the names here. We need to get those out. And I'm wondering about this. Well, I don't think we need to slice. I think we just need to grab them out. So we have like an intermediate query. We have to get like all the components. Let components is equal to I don't know how I'm gonna do this because we have to query for, we have to get them from the hash map and throw them into these components. This can be just a nice empty vector here. Make you mutable. Then we're going to for name and names. We're gonna get the component out of the hash map. So that's gonna be, well, it has to be an if let, right? So if let some component is equal to really components, but then if I want to push them in here, so it's not like a queried, and these aren't the results because like these are just like the raw components. Let's do raw, like it's like an intermediary, but I don't want to lose access to this, so I don't know what the best name is. Self dot components dot get, pass it in the name dot 0. Okay, so then we're gonna get these raw components out, and I just want to throw these into components. Components, push, raw components. Now, if we can't find them, if it's a none, we need to immediately return an error. And this is component not found. Oh, Ash Darkfold, hello, good morning. You're looking for YouTube. I don't have a, I should add that as a command in. Give me a second and I'll give you my channel. Here it is. And I'll just go ahead and add that to the bot right now. Where's my commands? System. Command, yeah, bang, YouTube. Just responds with that. Everyone can do it. Sure. Submit. Let's try that again. Bang, YouTube. There we go. Yeah, good morning, Ash Darkvold. How are you doing today? Oh, you've been looking to rest recently, so you thought you'd check it out? Nice. I hope that you enjoy it. What do you need? Component not found. String. Okay. So this is going to be the name dot to owned. Name dot 0 dot to owned. Dot into. Oh, it's night where you are. Yeah. That's I like, it's early enough for me that like almost nobody around here watches me. Most people like prefer to sleep in. So I do get that a lot. So good evening or night. All right, so then we error out if we can't find it. So we push all these components in. All right, so we have all the components pushed into here. Now, and it's just a reference to like the vector coming out. Then we have to figure out like what these indexes are that we care about. So for each entity in our bitmap, we choose like, are we adding the component? We go down and we choose, okay. Does it have it? If it does, go ahead and update our current name indexes. If it doesn't have it, we're not going to update the current name indexes because we're skipping over it. And now we say, hey, we're not adding this component. Now, if we're adding the component, then we want to take the name indexes and this is why we only need one level of the name indexes. We're going to loop through the name indexes, and then for the components, for each of the components of that name index, we add that into the results. So how is this going to work? We want in here in results, we actually need to be components, don't we? Either that or we're slicing out and removing. No, because does that even make sense? No. I think you need to be a vector of vectors. Oh, but I don't even know which one this is. So do I need to be returning essentially a vec of that? Which means in here we do another vec. And then we're going to be pushing into here. And then you are going to be the length of the current, like the names dot length. So if we're adding the component, we want to take our components and the current name indexes. So components are pretty much the same. It's this vector of component data too. So we loop through all the components. Component in components. And then grab the current name index out of them. I don't know if it's the current, if it's going to be this, because that's going across. No, because that is going down like that. So if I hit her and enumerate, this would be the entity index, and then we have the component itself. Then is that true? Components in here is like a vector of these. So we have like entity index, entity index, entity index. We have a bunch of components like this. And you're a vec of component data now. So we have like this here. We also have like this index. But the next time through, we're going to have this index and this one. That doesn't seem right. I think I'm doing this wrong. Like we're getting close. Okay, so we've updated. Oh wait, we already have the entity index here. Oh, okay, hold on. We already have the entity index here. We're inside of this for loop. If we have that entity index, then we can use the current name indexes to reach into the components. We loop through these components to give us each of the vectors, and we use the entity index to add them in. And that's only if we're adding them. So if is adding component, then loop through those components. Components. Then add the entity index of that components into the results. So it's going to be results of entity index. And we're going to then push into that the current component. Wait, no. Because results is down too. So hold on. That may not make a mistake. That may not make sense either. Results. We have to know which component we're adding now. Do I need to enumerate this to get the index of this one, which is the vertical going down? So this is the component. So iter enumerate. So this is the component index, and then the component itself. So results we want to go down. So this can be the component index. And then we're going to push in the component. Push in the component of entity index. No, the current index. Of the component, the current index of the component index. This can be the current name indexes of the component index. This is so convoluted. If this works the first try, I'll be absolutely amazed. I can't imagine. This is so I think I've just way overcomplicated it. That's my gut feeling. So if we've done that, and then we return, we reach the end and we return the result. Smash types. And I want to push just a reference to you. I mean, so you're not unhappy with me borrow checker wise. Logic wise, I have no idea if this is going to work at all. Let's go ahead and fix you. So in our query, we need, what do we need? We need the names, the bitmap, and the bitmap. But the bitmap is going to be the query off of here. So we're going to do query here. So let bitmap query equals self dot bitmap dot query, pass it in the names. Oh, I don't need this like component thing. So we need to strip that out. It sounds like I don't necessarily need this in here too. I might just need that. And then we're going to return the result of you. And so we've discovered that you're actually this. Expected struct. Okay, yeah. So then in here, you're really just this, which means wherever we do like this names 1, name 0 thing, no, it's name. It's just that. Okay. Cannot assign twice to immutable variable is adding component. That's because you need to be mutable. Names gets moved into here. We can clone you, maybe? Then it's just Asteroids having problems. Okay. Perfect. So then if we come into our integration test for querying, query for entities when all entities have the same number of components. So we create these components here. So components equals world.query. Right, it's just going to be the names now. So we just want the location name and size name. All we want are locations and sizes. Like something that has both of those. So we would expect that locations equals component 0 and sizes. We expect you to have the same length. Right, okay, so querying for multiple components. I may have broken that completely. So I'm going to ignore you. Cannot move out of vector because it has component data, which it's not. Okay, what if I just do that? All right, you're not upset with me. Let's run the test. Okay, so query for entities when all entities are panicked at index out of bounds. The length is 3, but the index is 3. Okay, so this is entity data line 82. So one of these was the wrong one. So I could check you. So we could debug. was either current name indexes or the component index. One of you two. Epic Blarg, hello. How's the project progressing? It's in the hard part now. Borrow new value. Okay, fine. Don't actually move it. Just reference it there. That's fine. It's we're in the interesting point where I'm trying to like now use the bitmap to query for this. Oh, I need to do the, oh no, it doesn't. Okay. So here, the current name indexes is 1 and 1, and the component index is 0. Okay. Then 1 and 1. Then 3 and 2. So current name indexes is 3 and 2. That does seem wrong, because then I'm trying to get the length is 3, but the index is 3, so I try to get this out. And I'm starting with the indexes being 0, so we do see that here. Is that correct? No, we see you already at 1. Oh. Because we're starting at like plus equals to 1 here. This is assuming we've never seen it before. Like we need to increment it only if it's like not the first one. I mean, I wonder if, well, because they need to be use sizes, they need to. So I couldn't do something like set this to -1. That would make you upset because it can't be a negative U size. I would hate to do a flag just to determine whether or not I should do this. Like if it's the first. Like we could do the first one by hand and then set this. We can use these as options. What else could we do to like okay, I could increment this by first and then current name index, components bitmap index. So current name index, I could like then set as a like, I don't know, it feels so bad to do this as like a -1, but then change it to be here. So like wherever we're using. And if I did that, then suddenly you can be an I-32. I feel that this is actually a really like bad hack. I don't like it. It worked though. Like it worked. The test passed. Can I explain what I just did? Yeah, absolutely. So this is a big fun thing here. So we need a graphic for it. It looks sketchy. Oh, it's super sketchy. It's the sketchiest. Okay, so here we have a list of entities across the top, and then all the components for each entity. Note here that the message entity is missing a component in, like, it doesn't have a velocity, but everybody else does. So if let's say I'm querying for all locations, all velocities, all markers, and all is deleted. Everything has it except message doesn't have a velocity. So instead of using options, I'm just having these be vectors of the data, which means this velocity vector has a length of 1, 2, 3, 4, where everything else has a length of 5. But I have this map here that tells me that it's a false here. So what I want to be able to do is I want to say, okay, location, like everybody has this one, so this gets added in to the this gets added. Okay, cool. Everybody has this one. It gets added. We're still fine because the indexes line up. Then we get here and we're like, nope, everybody doesn't get added, but because these have values, I need to increment, like I need to store some kind of index, like the current index that I'm looking at. These get updated. This one stays at 0. And we move on to this one. By the problem that I was running into is over here in code, I'm saying, hey, I found, like, update the name, and it's basically, I found that you exist, like you're a true in the components index. Let's go ahead and update this bitmaps. Now what I could do is, if your current name, if you're a 0, no, because like even if you're 0, I want to increment it. Yeah, I want to increment it, but not the first time. So either I'm gonna be doing, I guess, like if entity index is 0, so then this would be like if entity index is not equal to 0, then go ahead and do this. I know it's like no matter what, even this is a little bit sketchy, but now I can set you back to 0 and you don't have to be cast as a usize. So you can remain a usize. And if I do this again, you can run the test and it should just pass. Okay, it passes. This also means that I can come in and remove this debug. Okay, so it runs. And so you can see here what I've done is I've spawned 3 entities, 2 with both location and sizes, and 1 with only location. And I want everything that has location and size. Give me all the location, all the entities that have both location and size, meaning that we should not get this one. So, I've asserted that the lengths are equal. So like I get back locations and sizes that are the same length. Now I should verify that I did not get this one. All the locations that I have are different, different here. We have like first location, second location, and third location. So I can just do a few asserts here to make sure that like what we actually have is what we expect to have. So we want locations of position 0. Now this is just component data, so it still needs to be cast out. So I don't think I can do this yet. Let queried first location. You're going to be equal to locations of position 0. Oh, I have tea. Thank you. It's nice because it's cold down here too. Okay, that gives me this reference to the component data. And I need to cast it, which is going to give me this like RC ref cell. So if I cast it and question mark U, so you're going to be a reference to an RC, a ref cell, and inside of that, you're a point. So queried first location should be this. Then I believe, okay, I can then just do an assert equal query. Oh, we have to do this entire thing. You're kind of like a wrapped one, because I don't think I can borrow you at this point. So that like a wrapped queried first location, queried first location. Keep on saying queries. Equals. Okay, it's going to be our wrapped queried first location. We're going to borrow this. That gives us our ref of a point, and then we can assert equal our queried first location. We have to dereference it. U should be equal to the first location. Okay, so you're still interesting equal to the first location. And then if I do this for, we should only have 2 of them. Let's also assert that. So assert equal that locations dot length is equal to 2. Okay, so we only got 2 out, so that's good too. So then, okay, so then I could just do this for the second one. So queried, this is now going to be the second location. But you're not the second location, are you? Because you should be the third location. Okay, so left is 0.00 and the right is 10, 10, 0. Oh, also you should be position 1 because there's only 2 of these. And our third location is 15. And we're using third location here. And so we should only get the third location. We should only get the third location. So the queried second location should be equal to the third location. So if I set you to be the second location. Here, we should get this as an error. This should fail saying that it's, we had 1500, but we're checking to see if it's a 1000. It worked. How does that work mostly first try? I need to keep this test because this is that is a nasty algorithm. So then I want to turn this test back on. Like I want to redo like normal test 2, like ones where everybody has everything. I just have like one entity. I'm trying to get this out. I'm querying for multiple components at the same time. It's just location, name, and size. So this is location name, size name. It doesn't work. Why? Versus it works. Why? That's true. Okay, locations. We don't want to move out of this. We get you out, we cast you here, and then we check to see if you're all equal. Okay, so then do all these tests run. Yes. So then, this is BBECS, cargo test. Everything just works, okay. Cool. Let's go ahead and clean up some of these warnings. Yeah, I experimented that very briefly. Key code is not being used in here. You're not being used in here. Oh, and component type. We don't need this anymore. Wait, is that true? When we register for entity data, right? We don't need it anymore because we just register the name. Insert name, components, which is just an empty vector because component data goes inside of that. So we don't need you as component type, doesn't come in here anymore. That's actually going to cause errors. Let's go and fix that really quickly. So, in register, we don't need to pass you in. We don't need to pass you in. So we don't need component type here. But that means we don't need you. Okay, don't need you. And there's something else in here. Okay, I don't need either of you. Okay, so no more warnings in there. Oh, all of my tests are broken. That's cool. Okay, don't need that. Oh, you want me to have a default for bitmap? Can you infer that? Yes, you can. Okay, so let's go ahead and fix these tests. So we don't need to tell you. Oh, when we register, we just tell you the name. Okay, cool. That'll make things easier. Okay, so need you. Okay, spawning entities, same exact thing here. All right, let's run this as tests again. Okay, everything is passing. Now I'm like, the complexity in this query is not cool. I don't like the fact that it's so complex. I don't know exactly what to do about it right now. So we're gonna need, like, the fact that I have a test for it, I'm really happy about. There's gotta be some easy wins for like fixing this up, like maybe just breaking things out into different functions. Probably like maybe even breaking out like each of the layers of the loop into different functions, potentially. That could help it a lot. A lot of the complexity comes from the fact that there's so many of these little vectors that are tracking little numbers. And if I can't figure that out, then we're gonna have to document the heck out of this, and deal with that. But that being said, I want to bump our cargo lock, our cargo to Tamal. So you're going to be 10. I'm going to close all of you down. I'm going to head on over here. So in BBECS, we now have able to query for multiple entities that have different components. So I'm in this bitmap branch. So I'm going to go ahead and push this up, and then I'm going to create a, let's see, I'm also going to push up this master branch that we have. I want to pull request. Let's see, how does this work again? I want to go to master. I want to create a pull request from bitmap to master. There's no problems here. So this is going to be adding the ability to query for multiple components at the same time. Also, not all entities have to have the same number of components, which is really cool. So thanks for Utsby for helping us out with like sort of knowing that the bitmap is going to work for that. It's a bit complex, but I think it should help out a bit. Now, that being said, we do have some tests working for us here. So I can't pull this in until our tests complete. Once the tests have finished, I can hit the pull. Then it will auto merge in, do more tests, and then auto push and deploy to, oh, all checks have failed. What happened? Okay, never mind. Apparently we're gonna have to wait until Azure doesn't have problems. IP address not found for Ubuntu, for like grabbing Ubuntu. That's cool. So yeah, I will do this later. I'll I'll see if I can try it later, hopefully before tomorrow morning, and then we can get onto it. All right. Until then, I'm gonna go ahead and switch over to the ending screen.